Now, before I go into any details on this problem, I need to point out something. The screenshot here kind of lopped off. This is really 10 cosine 2t, not just 10, not just cosine 2t. Now, with that said, we're going to go ahead and get started here. And I do want to point out that this is the first chapter 10 problem where we did not already have things in terms of J on impedances. And that's important that you know how to convert to get J. That's a skill that we saw in chapter 9. And I promise you that you'll have at least one problem on your next exam where things are not in terms of J at the beginning. You need to convert them yourself. But there's actually a bigger reason here on this problem why they're not in terms of J. When you go to find the impedances, for example, the impedance of an inductor is J omega L. Well, there's a real problem there because you need to plug in what your omega is, and yet this source has an omega of 2, and this source has an omega of 5. And so you might say, well, what do I use for my omega in that formula? And the correct answer is actually going to be both, but at different times. So the thing is we need to learn how to handle sources of different frequencies, and it is only thing that we can do to handle them is to handle one source at a time, which means this is a problem that is absolutely required to use superposition. This is the problem I've been warning you about for months now, that superposition is not just useful sometimes, but there are times when it's actually required, and this is one of those times. And so what we're going to do is we're going to solve the circuit with one source at a time and having different omega values each time, and then at the end we're going to put it all together to get our final answer. Okay, so let's go ahead and just look at the first source here, which is the 10 cosine 2t. We have our inductor. Current source becomes an open. We have our resistor and the voltage we're trying to find. We have our capacitor. We have our other resistor, and voltage source becomes a short. Then we're going to go ahead and convert this into phasors. 10 cosine 2t is 10 angle 0. 2 henries. So it's J omega L. My omega is 2 here. My L is 2. So I'd have 4J. For a resistor, it's just the same that you start with, so 1 and 1. For a capacitor, you do negative J over omega times C. Well, omega is 2 times C is 0.1. That's going to be 0.2, and 1 over that's going to be 5, so I'm going to have a negative 5J here. And then I will have a resistor of 4. Now I'm going to go ahead and combine the 4 and the minus 5J. And I would get, let's see here, 4 times negative 5J is negative 20J over the sum, 4 minus 5J. And so now I have the circuit in just a nice series here. So by voltage divider, I can find V0 is the total times the impedance I'm at over the sum of the impedances. And I'm going to choose to put that whole thing in my calculator to save myself some effort. And let's see here, 4 minus 5i. And if I go straight to writing it into polar form, because that's what we like to have it in, It's going to be 2.50 angle negative 30.8 degrees. And so I'll make a note of that here. So we're going to start over again, but my first one, the V0 I got is 2.50 angle negative 30.8 degrees. And then I need to now look at the second source, and we'll go ahead and look at just that one here. So voltage source goes away. I have my inductor. I'm going to go straight into phasor to just save myself some time here. Now 2 sine of 5t, 2 sine of 5t in terms of phasors would be 2 angle minus 90. Remember, when you have a sine, it's going to become a negative 90 here. And my omega for this one is 5. So for j omega L, I would have 10j here. And then I have my 1. And then let's see here. 5 times 0.1 is 0.5. 1 over that is going to be a negative 2j. 4 and short. And so I can decide what I want to do at this point. Maybe what I'll do is I will do a source transformation here. So I'd have a voltage source. So 2 minus 90 is the same as a minus 2j. Right, by doing cosine and sine here. So minus 2j times 10j is going to be positive 20. And then I have my 10j inductor, my 1. And if I combine those two in parallel, then I would have a negative 8j over 4 minus 2j. And this time I can get my V0 total times impedance I'm at over the sum of the impedances. And once again, I'll put that in my calculator to save some time. Divided by 4 minus 2i. And putting it into polar. This time I get 2.33 angle negative 77.9 degrees. And there is one more source here. And the thing is, in that case, that source has an omega value of 0. And the reason why is cosine of 0 is 1, and the cosine drops out. So in that case, we have an omega of 0. So if you look at, say, an inductor, j omega L, well, that's just 0 there. And in fact, we learned a long time ago that if you have a DC source for a long period of time, that an inductor behaves as a short. So that's what we just saw. And if your omega is 0 and you do 1 over omega, you're going to get infinity, which is the same as an open circuit. And so for this last source, inductor becomes a short. Get rid of the current source and voltage source. We have a capacitor becomes an open with regards to this. And it becomes a really simple circuit to analyze. The only thing you want to be careful with is that my source is kind of the opposite way to my V0. So it'd be negative 5 times 1 over 5, or negative 1 volts. And so at this point in time, we're going to combine all our answers together. But I do want to warn you, even though we're using superposition, we cannot just add these complex numbers together. And the reason why we can't is because these complex numbers depend on your omega value, and for each source you had a different omega value. So you need to convert each one of them separately back to cosines and then add them up. So my final answer would be from this first one, 2.50 cosine The omega here was 2t minus 30.8 degrees plus 2.33 cosine. This one was an omega of 5t minus 77.9 degrees, and then minus 1 from this third one here, and this would be your answer. So whenever you have sources that have different frequencies, like this, then you need to go ahead and do superposition, otherwise you can't solve it. Now hopefully by now you haven't seen enough examples that you can do your Chapter 10 homework, but I'm available as always in our Zoom meetings if you have more questions.